Hello everyone, this is a video for interval notation, and it is meant to be taught or watched before lesson 1-6, before we start introducing different characteristics of graphs using intervals. So what is interval notation? It's kind of like an alternative way of writing where a graph exists or where different characteristics exist, such as positive and negative, using something other than inequality form. So you guys are used to something that looks like this. It looks like -2 less than x less than or equal to 3. You might be used to something that looks like x is greater than 3. This is just going to be an alternative way to write those intervals. And your worksheet here says it's a faster way to list a set of numbers using parentheses and or brackets. A lot of people think that it is a little bit easier than inequality notation, and we do use it a lot in some of the more advanced mathematics such as pre-calculus and calculus. So let's start with interval basics. If you have an open circle on a graph, if you know it is not equal to, like if it's a boundary, it's got a hollow circle, what you're going to do is use parentheses next to that number to indicate it is up to the number but not including that number. If you have a closed circle or something you know is equal to, you're going to use brackets. Those are going to go next to that number, and you're going to indicate that it is equal to that number. If you have a negative infinity or a positive infinity, it's going to represent a very low or a high level in that set. You're always going to use parentheses because you are not able to be equal to a concept such as infinity. So there is one other thing that we do need to talk about that is not on your notes. So find an empty space here. That is called a union. It looks like a really big capital U, and that denotes or, and you're going to only use that if you have two different intervals, two or more, in a graph. Let's look at example number 1. So we have a compound inequality. It is an and inequality. We are going to have to number our number line first. We're going to put circles at our boundary numbers, -2, +3. Now we're going to leave -2 open because it is not equal to, but we are going to close the 3 because it is equal to, and then the x between means that every number between our boundary numbers are shaded. So this is inequality form. And we are going to write it using interval notation. So the way that you write interval notation is you start with your leftmost number, which is -2. And we're going to put parentheses on the -2 because it is not equal to that. And then we're going to separate those two boundaries with a comma. And then our rightmost number is a 3. And we're going to use brackets this time because it is equal. Okay, next up we've got a one-way inequality. I'm just going to put 8 here in the middle. I only have one boundary number. So I have a circle here. I'm going to leave it open because it is not equal, but it says x is greater than 8, and I will shade all of the numbers that are greater than 8. So if I'm going to write that using interval notation, I'm going to use my left boundary at +8. And I'm going to use parentheses because it is not equal to. But what is my right boundary? I don't really have a rightmost number. It's actually going to be positive infinity. So if you have a graph heading to the right forever, it will be positive infinity. And if it is shaded to the left, it's going to be at negative infinity. Or it'll actually start there because that would be the leftmost point. But in this case, it is heading to positive infinity, and you have to use parentheses around that. So the last example on the front page has us do both notation. So they've given us an already graphed number line. We do need to find out that these lines are increasing by 4. So this will be 12, and this boundary would be 24. So it goes everywhere between 12 and 24. So I'm going to write 12, and I'm going to write 24. So on the inequality section, notice I left a lot of space. The reason why is because your x has to go between the two, and since it's an and inequality, you will be using less than. So it's automatically going to be less than because 12 is the least of everything in that statement. The only thing you do have to check is if any of them are equal. 12 is equal to x and 24 is not, so I'm going to leave it just like that. So interval notation, on the other hand, we're going to do 12 comma 24, and then we just figure out, do we use parentheses or do we use brackets? So bracket on the 12 because it's equal, parentheses on the 24 because it is not. So in this section of the video, we're going to do a pretty thorough review of domain and range, but we're going to be doing it on a coordinate plane. So you have 2 dimensions instead of 1 dimension, and it will be a continuous graph. So we're going to pick 2 highlighter colors. I have one color for domain. I'm going to use yellow, and then I'm going to use purple for range. Domain is all of the possible x values, and then range is all of the possible y values. So what I'm going to do is I'm going to write the word domain next to each one of these graphs on the x-axis. Domain. So we've got to figure out exactly the leastmost domain point and the rightmost domain point. We're going to do the same thing on all of these graphs. And what I'm teaching you right now is going to apply to every graph that you try to find the domain and the range of. Okay, let's head back up to that first example. And I'm going to ask you to see if you can find the leftmost point on this graph. Where is the leftmost point? So it doesn't matter how high or how low it goes, leftmost point. And I'm hoping that you are looking at this point right here. Now I understand that that is not on the x-axis, and that's okay. It doesn't need to be on the x-axis. You just have to find where it is on the x-axis. So it looks like it is at -3. So the leftmost point of our graph is -3. What is the rightmost point? It's over here. And if you see, it is 8. I do not care how high or how low because that would be a range value. So I'm going to take my highlighter, the yellow domain highlighter, and I'm going to highlight everything between -3 and +8. So if I'm going to write the domain using interval notation, I'm going to start with the least number and the greatest number. But we need to consider, is it equal to -3? Is it equal to +8? Well, if you look at the graph, you have a very obvious hollow circle right there. So if that is an open circle, you will be using parentheses. Same over here on the right, it is also open, so it'll be using parentheses. So you may ask, well, when do I use a bracket instead? Well, pretty much any other time. If it's a continuous line or a curve, it's going to be equal to. So just keep that in mind, and we'll do the same thing over here in number 5, because you can see that one of these dots is open, but the other one is closed. Now, it just so happens that the end point of this graph happens to be the left and the rightmost point. So it's not always going to be the end point, so just keep that in mind. So this one starts here at -1, and it goes all the way up to 8. So if I highlighted the domain interval, it would go between -1, +8. I would have parentheses by the -1 because it has a hollow circle on it, and it is solid at the 8. I will be using brackets. If you look at question 6 and 7, those are absolute value graphs. That's what it's going to look like in your textbook on lesson 1-6. So it's kind of that lesson that you're going to watch right after this one. So if I ask you the same question I've been asking, what is the leftmost point? Some of you are going to be tempted to say it's actually at -9. Now that's not the case because we have an arrow, and hopefully we all know that an arrow means it continues to go in one direction, or that same direction. So it's going to continue to go left forever. So as it continues to go left forever, that indicates -infinity. Same thing on the right-hand side. It's going to keep going to the right forever. That is +infinity. and we always use open parentheses with those symbols. If you look at number 7, yes, this graph is different. No, it does not have arrows on there, but you know it's an absolute value graph because of the shape. So you're going to draw these arrows in here, and you're going to think, do I have a leftmost point? Do I have a rightmost point? I don't. They're going to continue to go forever in either direction. So it's going to go from negative infinity to positive infinity. Now let's talk about range. So it's important when you go from domain to range that you need to understand that you are now looking at the lowest value and the highest value, and that's more commonly known as your minimum and your maximum values. So if we looked at this right here, let me use a different color. We're going to do range. I'm going to use a purple highlighter. What is the minimum or the lowest point that you see on this graph? Well, it happens to be the same point that we used before, but the difference is I want to know how low this goes on the y, not the x. So it actually hits at negative 11. The uppermost point is the same one over here, but we want to know how high, or what is the maximum point, and that is 5. So as we write our interval notation, we're going to go least to greatest, negative 11 to positive 5. Both of those points were hollow. They are not equal to either one of those, so we're going to use parentheses. All right, let's look at the next one. Now, when I'm teaching this next one, we normally have a lot of people pick the wrong points because they're not truly looking for a maximum or a minimum. What they're doing is they're looking at the end points. So they're looking at these circled points here, and they're saying that the maximum is at positive 2. Is the maximum at positive 2? I don't think so. I see part of this graph that goes all the way up to here. So it looks like 9 is the maximum point, and if you look below, negative 9 is the minimum point. So you have to go in order. Oh, I forgot to do my highlights, so let's do that right now. You can go back and do that highlight on the last one. So I'm going from negative 9 to positive 9, and you have to ask yourself, what kind of points were those? Well, they were part of a continuous line. There was no hollow points at 9 or negative 9, so they are equal to, so I will be using brackets on that one. You go back over here, let's highlight from 5 down to negative 11. So I think the easiest thing for you to do is just focus on lowest to highest, never go the other direction. So always least to greatest, which is maximum to minimum. Oh, I'm sorry, minimum to maximum. Okay, so if we're looking at the range here, I do have a lowest point at my vertex right here. So that lowest point happens to be at negative 5. But what is the highest point? I have arrows pointing up. So it looks like I don't have a highest point, so I'm going to have to use an infinity. So I'm going to scroll up just a little bit. Start with your minimum value of negative 5, and it's going to go all the way up to infinity. I made a mistake. That negative 5 there should be equal to, because it was continuous. And if I was going to shade using my purple highlighter, I would start at negative 5, and then I would just go up all the way to the top of my graph. Okay, let's take a look at question number 7. So the lowest point we have doesn't exist because I've got arrows pointing down. So I'm going to start at negative infinity. What is the highest point? That highest point is at positive 3. So I'm going to put a 3 here. It is equal to the 3, and I have parentheses on the negative infinity. Just let me know if you've got any questions on your interval notation, and you should go ahead and start watching the video for lesson 1-6.